This is Laura Duncan from CSMS. Today we'll learn about adding polynomials. In the 8th grade we have added polynomials before. We called it combining like terms. And when we combine like terms, they must have the same variable, such as x, and they must have the same exponent. So if I have an exponent of 1, which we usually just write as x, and an exponent of 2, these are not like terms. So in our study today, combining like terms basically means that we are combining shapes that are alike because it has the same variable with the same exponent. So let's take a look at the first problem. Remember, x squared is represented by a square. Those are like terms. So when we have x squared plus x squared, how many x squareds do we have? Well, that would be 2x squareds. The coefficient 2 represents how many squares there are. Let's look at the x's. So we would write this first term as x squared. Added to that would be 2x's because there's 2 of them. In the second polynomial, we have x squared plus 1x. And this is the sum of those two polynomials. We have 2x squareds and we have 3 x's. So the coefficient will be 3, and what that means is 3 times x. So the sum of this polynomial and this polynomial is this. Let's look at the next one. In the next one, let's write this completely. So we have 3x squareds, 1, 2, 3. So the coefficient will be 3, and it's 3 times x squared. The second term will be the x's. There's 2 x's, so we'll add 2x to it. And finally, there's 3 units. So we'll have 3x squared plus 2x plus 3. Let's look at the next polynomial. We have 1x squared, so the coefficient is an understood 1 right here. We have 1x, so we'll add that x to that. And then we have 4 units. So as we're drawing these, now we'll represent their sum in the last blank. So we'll draw a picture. In the first term, we have 3x squareds. In the second one, we have 1x squared. Then we'll draw 2 x's and 1x. And lastly, we'll draw 3 units plus 4 units. Now we'll represent the sum algebraically. How many x squareds do we have? So there's 1, 2, 3 blue ones and 1 red one. So that's 4x squared plus 1, 2, 3 x's plus 7 units. So the sum is 4x squared plus 3x plus 7. Some of you probably have already noticed that when we have 3x squared plus 1x squared, we're adding the coefficients to get 4x squared. When you have 2x plus an understood 1x, 2 plus 1 would be 3x. And finally, we have 3 plus 4 would be equal to 7 units. Now there's something else at play here. It's called the zero principle. When we add a term like +1 and -1, their sum would be equal to 0, which essentially means they cancel each other out. The same thing happens with negative x added to x. Their sum would be 0. And again with x squared and negative x squared, their sum would be 0. So when we're combining these terms, you can cancel them out. There's a 0 pair, there's another 0 pair, and here's a third 0 pair. So the sum would be equal to 1. Here we have x's. So you're looking for a 0 pair. That's a negative x. That would cancel out with a positive x. We have another negative x. That will cancel out with a positive x. So what we're left with is 2 x's. But since they're darkened in, it will be negative 2x. And that is the sum of those terms. Let's look at example 3. These are positive x squareds. This one is a negative x squared. So we have 1 0 pair. And then the remainder, we combine the like terms, we have 2 x squareds. So going forward, look for those 0 pairs and things that can cancel out. So we have more adding polynomials. Let's first start with representing the first term. In the first term we have 2x squared, and notice these are the x's, but they're negative. So it's minus 2x, and there are 4 units, so that would be plus 4. In the second term, notice this is a negative. It's negative x squared, and then we have 2 x's, but they're negative 2 x's. And then there are 6 units, but it's negative. Now to combine these, we can look for the 0 pairs. So this would be a 0 pair. And you can see we have 1 x squared left after we take away the 0 pairs. For the x values, there are no 0 pairs. So we will simply have 4 x's. But because they're all negative, it will be negative 4x. And finally, we'll look for the 0 pairs in our units. That's a 0 pair. Here's another one. And finally, we have 2 units left, but they're negative. So be sure to fill them in. Now let's try to take the shapes and relate it to what we're doing over here with the algebraic way of writing things. So looking at the first pair, we have 2x squared minus x squared. There's an understood 1 here. So 2x squared minus 1x squared would leave us with 1x squared. We usually don't write the 1, it's understood. So for the next pair, we have negative 2x and negative 2x. If the signs are the same, you add and keep the sign. So we add them. 2 plus 2 is 4. It's 4 x's, and we keep the sign. And then lastly, we have negative 4 minus 6. Signs are different, so we subtract. 6 minus 4 is 2, and keep the sign of the greater number. So now you can see how we can treat the algebraic version of this without having to draw it out and remove the 0 pairs. So let's try some vertical adding. When we're adding these, remember there's an understood 1 here. We're adding the coefficients. So 2 plus 1 is 3. There's 3 x's, so 3 times x. For the next one, we have 4 minus 7. The signs are different, so we subtract. 7 minus 4 is 3, and we keep the sign of the greater number. So it would be 3x minus 3. Since there are no more like terms, that is the answer. Let's go on to number 2. Try number 2 on your own. Pause the video here. So we are left with 7w squared plus 11w. Can we combine those anymore? Are there any more like terms? Remember that your terms have to be alike. They have to have the same variable, which we have here, but they have to also have the same exponent. This has an understood exponent of 1. So this is the final answer. There are no more like terms to combine. When we look at horizontal adding, students find it easier if they can circle the like terms. When you're circling the like terms, be sure to include the sign. It's important to note that we are adding these, so be looking for that. Just put a star by that addition sign. So this is a positive 2w squared. So we're adding the coefficients. 5 plus 2 is 7, so 7w squared. Then for the next two terms, we have 8w, and that is like 3w. So we add the coefficients. 8 plus 3 is 11, so it would be 11 times w, which is the same one that we just did, except now we've done it horizontally. Let's look at number 2. Find the like terms. We have 4a, and we need to note that that's a plus sign. And we have negative 5a. The signs are different, so we subtract. 5 minus 4 is 1, and you keep the sign of the bigger number, so that'd be negative. And it's an a. We don't have to put the understood 1 there, so it's negative a. Let's look for some more like terms. We have 6ab. Any like terms have to have the same exact variables, which are the letters, to the same exact exponents. So those are two like terms. The signs are different, so we subtract. 6 minus 2 is 4, and it's 4ab, and we keep the sign of the greater number, so it's plus 4ab. Finally, we have negative 2b. There are no like terms like that, so it will simply stay the same. Then we go back. Always look for like terms. Are there any more like terms? No, there are not, so that is our final answer. Let's look at number 3. So what is a like term with 4? Notice that this is a plus sign, so that's good to note. So we have 4. The other like term is 1. So 4 plus 1 is 5. Then we have negative 3 plus 3. So negative 3 plus 3, well, that's a 0 pair. So that would be 5 plus 0. So the final answer would be 5, because these cancel out to a 0. Now, last question. So let's look for like terms. Which terms are like 8a? Well, there's no terms that are alike, because it must have the same variable to the same exponent. However, we do see a 2b. Since they're not like terms, we cannot combine them. And finally, we have the numbers, positive 12 and negative 10. The signs are different, so we subtract. 12 minus 10 is 2, and keep the sign of the bigger number. A and B are not like terms, and so we cannot combine them. So this would be the final answer. The lesson is yours.